I'm Sam. I'm an OpenSciEd teacher and facilitator. Today, we are looking at Unit 7.3, McKenna, Lesson 13. This is a major putting the pieces together lesson where we finally connect McKenna symptoms to the cellular level. Let's take a look at how we got here. To ground ourselves, during the last lesson, we figured out that this thing called cellular respiration happens in our cells when food and oxygen meet and give our bodies energy. In this lesson, we are wondering, how does a healthy body use food for energy and growth? And how is McKenna's body functioning differently? To figure this out, we will build models of 3 different pathways food takes in the body and use them to explain McKenna's weight loss and lack of growth. Let's take a look at a lesson at a glance to see how we're going to get our students there. This is a 2-day putting the pieces together lesson. There's about 25 minutes of prep time, which includes making the posters for the consensus model that the students will be making later in this lesson. Let's take a look at the overview of this lesson. I'm going to break this lesson into 3 big parts so that the lesson plan is more easily digestible. Let's take a look at those loops more closely. This is loop 1. It happens in part 1, which is building the checklist. What you'll do is you'll review progress trackers from lessons 8 through 12 to create a gotta have it checklist. We figure out that we identified the specific evidence needed to explain energy, growth, and storage. This leads right into needing how to actually put those pieces together in a visual model. Let's take a look at loop 2. In loop 2, that will be parts 2 and 3, where we model and compare the pathways. What we do is have our students in small groups create models for the 3 pathways and then compare them with another group. We figure out that we realize that matter is rearranged for different purposes and different groups have different ways of representing growth. So this makes us realize that we all have different ideas, which motivates us to come together to agree on one version in a science circle. And that brings us to loop 3. Loop 3 is going to happen over 2 days. It starts on day 1 and continues into day 2. It's where we're going to build the consensus model and take a look at McKenna. So we build a consensus model and apply it to McKenna's symptoms. We figure out we finally can explain why McKenna is losing weight and not growing, right? Because she has celiacs, which blocks absorption needed for these pathways. So this settles McKenna's case and motivates us to see if the same rules apply to other living things in lesson 14. So let me summarize what we figure out in these 2 days. On day 1, we figure out that we have lots of ideas as to how our bodies use food for energy, and we should probably work together to figure this out. On day 2, we know how a healthy body works and can use what we have figured out to explain all of McKenna's symptoms. Let's take a look at some key moments to help us get through this lesson a little bit more manageably. Key moment 1 comes on part 1, day 1, where we facilitate the checklist. You're going to start day 1 by creating a gotta have it checklist as a class. My big tip here is focus your students on their progress trackers. Have them look back at lessons 8 through 12. If you find they're struggling to remember what to include, ask them, what did we figure out about where food goes after the small intestines? This keeps evidence in their hands and not yours. I also recommend coming back as a class to create the consensus around the gotta have it checklist. It makes things go faster later on. Key moment 2 comes in part 3, where we have our students compare models with another small group. Now, you're going to have the students model 3 pathways. Pathway 1 is energy. and usually goes great because of all the work that we've done in lesson 12. However, in my experience, part 3, growth, is the most difficult. Why? Because we don't have direct lab evidence for it yet in this unit. So when the students come together to talk about how they think this is modeling, they begin to realize that they have very different ideas. If students get stuck on growth or storage models, remind them that food molecules aren't being burned immediately. That means the matter has to go somewhere. It can't just disappear. Remember, we learned this in bath bombs. This is a great time to lean into those I don't know moments. If a group is stuck, don't give them the answer. Instead, ask, what are we wondering about here? And ask them to add that question to the model. These questions bring authenticity to the lesson and help drive the need to come to a science circle. Our third key moment happens in part 5, which we're now on day 2. It's a weight loss revelation. One of the most important realizations in this lesson is how we lose weight. Students often think that weight leaves as poop. And you want to guide them to realize that when we burn fat for energy, it's a chemical reaction that turns solids into gases, CO2 and water, that we are actually breathing out. This is a total mind blower for middle schoolers. So where do we go from here? Well, we want to better understand if all animals work the same way a healthy human works. We will explore everything from single-celled organisms to complex multicellular ones. Now, before we move on, let's take a look at some tips and tricks that I've kind of figured out along the way that help this lesson move more smoothly. In part 5 and 6, this is on day 2 where you're building that consensus model. You really want to lean into the CCC of energy and matter. This should help the students come together to explain what happens to food molecules that are not needed right now, and what happens to food molecules that are needed for growth. Sometimes it just helps to put concrete examples with those generalized topics. For example, when you're talking about the pathway of what happens to food molecules that are not needed right now, you may want to ask the question like, well, what happens to food molecules if we just continue to eat too much? And the students typically respond with, we gain weight. Right. So that's what we're talking about when we're talking about food molecules that are not needed right now, right? We're talking about it's turning to fat in our bodies. So how might that happen? And when you're talking about the food molecules that are needed for growth, you may want to ask the questions, what are things that grow in our bodies? They're going to respond with things like bones, hair, nails. This is putting concrete examples to those really broad, generalized topics, and it helps the students build those pathways better. Remember, it's also okay if your class models don't look exactly like mine pictured here, or the one that's in the book. While you're in the circle, this is also a great opportunity to bring up related phenomenon, like other animals, to get students to begin to wonder if other animals' bodies work the same way as ours does, and that's going to help lead you into lesson 14. Now, let's talk about part 7. If you're short on time, have the students work individually, or I prefer, in small groups to develop an explanation for just one of McKenna's other body symptoms. Remember, our goal isn't a detailed medical description. The focus should be on reasoning through the connection between what the class figured out about how the system works together and how that impacts how McKenna's feeling, right? Where are those symptoms coming from and how are they affecting her other systems? If students struggling with their writing explanations, use this as an opportunity for them to give each other feedback on their work. Finally, in part 9, don't skip this. The reading provides closure for what they've been waiting for this whole unit. This could be a great home learning activity or a sub-day activity where they figure out about how McKenna is now doing. Poster management. Don't forget to make the posters of the 3-prong model ahead of time. Keep the models handy as they will be useful for the students in the next 2 lessons. I usually keep mine posted on the front board so that it's easily accessible to me and I can point to it, and also have the students come up and point to it in the next 2 lessons. Now that we've solved the human body, we want to know, do all animals work this way? In lesson 14, we'll do a deeper dive into organisms from single-celled to multicellular. To summarize, prepare your posters ahead of time. Focus on the reasoning in part 7 and use parts 5 or 6 in the circle to bridge to other animals. This is the lesson where all of your students' hard work pays off. Thank you for watching, and I'll see you in the next video. Happy teaching!